Hey everyone, and welcome. We usually think of numbers as just symbols on a page, right? Things we use to count stuff. But what if I told you they have this hidden visual life? That some numbers can actually be arranged into these beautiful, perfect geometric shapes? Well, today we're going to see numbers in a whole new light.
So to get us started, I've got a question for you. Think about the number 15. If you had to draw it, what would it look like? And I don't mean drawing the digits 1 and 5. I mean, what's the actual shape of 15? Well, it can look just like this. A perfect, stable triangle made up of 15 little dots. And this isn't just some random arrangement either. It's part of a whole sequence. This is what's known as the fourth triangular number. Pretty cool, right?
So how in the world do we get from a simple number to these awesome dot pictures? Well, that's what we're going to dive into. We're going to explore how to build them, and you'll see it's actually surprisingly simple and honestly incredibly satisfying.
Now, there's an official name for what we're looking at. They're called figurate numbers. It's just a fancy way of saying they're counting numbers that you can arrange into these neat geometric dot patterns. We just saw a triangle, but as you're about to see, we can make squares, pentagons, and a whole lot more. And here are the two big ideas, the simple rules of the game. First, we build these shapes in steps. We just add a new layer of dots around the outside each time to make it bigger. And second, and this is the real key, we're going to look for a simple pattern in how many new dots we're adding with each layer. That's it. Let's see how it works. Okay, now that we've got the rules down, let's open up our gallery of shapes. We're about to take a quick visual tour of the first few figurate numbers, from the ones you might know to some really fantastic-looking ones. And here are our old friends, the triangular numbers. We start out with a base of 3 dots. Then we add a new row that has one more dot than the last one, and we get 6, then 10, then 15. You see? Each step just builds a bigger, perfect triangle. Next up, a shape I'm pretty sure you'll recognize, squares. This is such a cool way to actually see what 2 squared, 3 squared, and 4 squared look like. We start with a 2 by 2 square of 4 dots. Add a layer, and we get a 3 by 3 square of 9, then a 4 by 4 of 16. It makes perfect sense when you see it. Okay, let's get a little more interesting. Check out the pentagonal numbers. We start with that 5-sided shape of 5 dots, then just expand it outwards. The sequence goes 5, then 12, then 22, then 35. You can really see that add a new layer idea at work here, can't you? Let's move on to 6 sides. These are the hexagonal numbers. They build out just like all the others, giving us the sequence 6, 15, 28, 45. And hey, wait a minute, look at that. There's the number 15 again. So it can be a triangle and a hexagon. Interesting. Now we're looking at heptagonal numbers. That's 7 sides. Starting with 7 dots, the shape just kind of spirals outwards into these really beautiful, intricate patterns. For these, the sequence is 7, 18, 34, and 55. And to finish our little tour, here are the powerful 8-sided octagonal numbers. They follow the exact same rules, growing layer by layer, giving us 8, 21, 40, and 65. So you see, from a simple triangle to a complex octagon, the core idea is exactly the same. Okay, that was a pretty beautiful gallery, right? But the real magic isn't just in the shapes themselves, it's in the pattern of their growth. How exactly are we getting from one step to the next? Let's take a closer look. Now this is where the secret rule just reveals itself. Just look at the pattern here. For a triangle, which has 3 sides, the number of dots we add goes up by 1 each time. For a square with 4 sides, it goes up by 2 each time. For a pentagon with 5 sides, yep, it goes up by 3. Do you see it? The amount we add is always just the number of sides minus 2. So the most important thing to realize is this isn't random at all. The growth follows the simple, totally predictable rule. The number of dots we add at each step is what mathematicians call an arithmetic sequence. It just means we're adding the same amount each time. And that amount is tied directly to how many sides are in our shape. Now, of course, mathematicians have all these algebraic formulas to calculate any of these numbers you want. But let's be honest, formulas can feel a little abstract, maybe a bit boring. What if we could actually see the answer right there inside the shape itself? This is where we just kind of shift our perspective. Instead of reaching for a calculator or trying to remember some complex formula, let's just use our eyes.
What if the secret to counting all those dots is just a matter of looking at the shape in a clever new way?
And boom, here's the trick. Look at how we can just slice up this pentagon into a bunch of triangles. Since we already get how triangular numbers work, we can use them as building blocks to easily count the dots in a way more complex shape. This is a technique called triangulation, and it's basically a visual shortcut to the answer. No complicated formula needed.
And that right there, that's the big idea for today. The shapes, the geometry, give us this really powerful and intuitive way to understand the formulas and patterns of algebra. It's such a great reminder that math isn't just a bunch of abstract symbols, it's about seeing these deep, beautiful connections all around us. So we've seen that numbers can form these flat, two-dimensional polygons, but that leaves us with a really fascinating question to think about. What other shapes could numbers make? Could they be three-dimensional? Could we build pyramids or cubes or other 3D objects with them? The world of numbers is just full of these amazing patterns, just waiting for us to find them.